Lesson 4, number line and sequences. So when we have a number line, I'm pretty sure you guys have all seen a number line. Just draw a straight line there. We have a -3, -2, -1, 0, 1, 2, 3. These two numbers, the 1 and the -1, are called opposites. As we go above 0, so as we go to the right, our numbers start getting greater. They just get bigger and bigger as we go on up this way. As we're coming to the left, our numbers are becoming less and less. They're actually becoming smaller. Integers are all these numbers that you would find on a number line. They consist of all the negatives. So we have to have the 3 dots because the negatives are going to continue going on. So we have to have our ellipses. -3, -2, -1. They also have 0, 1, 2, 3, and so on. So all of these numbers, all the whole numbers plus the negatives, are called integers. Opposites are numbers that are the same distance away from 0. So if you notice here, here's 0, 1 is 1 unit away, and -1 is 1 unit away. 2 is 2 units away, so 2 units on the left is -2. So they're the same distance away from the number 0. So here's an example, 3 and -3. Those are opposites. -8 and 8. Those are opposites. Now we're going to go over some signs that we use in math. We have an equal sign. That just means equals. We have a greater than sign. That's read greater than. Notice that on the left side, it's open really big. So when you read left to right, it's greater than what's on the right side. If we go this way, this is less than. Notice that on the left, the 2 lines on the less than sign are together, and they're less than, closer together than the 2 on the right side. So if we had 6 plus 3 equals 9, we would use this symbol equals to show that they are the same amount. Greater than, we could say 5 is greater than -1. On a number line, 5 is to the right of -1. So it's greater than. And then we have -2 is less than 4. And that's because -2 is less than 4. It's on the left of 4. So you can use a number line to subtract integers. So here's an example. If we wanted to do 4 minus 6, first you draw a number line. So we're going to have our number line here. Put 0 in the middle. 1, 2, 3, 4, 5. -5. Put in your other integers. And number 2, start at the origin. Now the origin is the number 0. So we start at 0. 3, you're going to draw a line to the right 4 units. And you're going to the right because it's a positive, and you're going 4 because your first number is 4. Your minuend is 4. So we're going to draw a line 4 to the right. Actually, that's not a line. If we put an arrow, that's a ray. It's called a ray. A line has arrows on both sides. And then the last step is you're going to draw a ray left 6 units. So right from where you were at, you just come up here, draw a line, a ray left. So we know to 0 is 4 units, so we have to go 2 more. And then we're going to circle our answer. So we just drop down -2. So 4 minus 6 equals -2. Sometimes when we subtract, our subtrahend is bigger than the minuend. So notice here our minuend, 376, is less than our subtrahend, which is 870. So one trick or way that we do this is we switch the two numbers, put the bigger one on top, subtract the smaller one, and then your answer will be negative. So what I do is I just put my negative sign right there, so I don't forget that's going to be negative. So then we subtract the way we always subtract, and we get 494. And that would be the answer to this subtraction problem. That's the number line. Now we're going to go over what sequence is. Sequence is an ordered list of numbers that follow a pattern. Just any pattern. If it follows a pattern, it's called a sequence. We have an arithmetic sequence. And that has an addition pattern. I'm going to give you an example of an arithmetic sequence. So here's my example. 1, 3, 5, 7, 9. Hopefully you can see the pattern here. We're adding the same number. So to go from 1 to 3, we add 2. To go from 3 to 5, we add 2. 5 to 7, add 2. 7 to 9, we add 2. So this is an addition pattern, so this is called an arithmetic sequence. Everyone say arithmetic. Again, arithmetic. Good job. The next one is called a geometric sequence. This has a multiplication pattern. So here's an example where if we have 1, 3, 9, 27, and so on, we can see that we are multiplying from 1 to 3. We multiply by 3, from 3 to 9, multiply by 3. 9 to 27, we multiply by 3. So because we're multiplying by the same number, it's called a geometric sequence. We can write sequences using formulas. So here's a perfect square sequence. K equals n times n. That just means whatever n is times it by itself. So K is the number in the sequence. So that's the answer of each. That would be like the 1, 3, 9, 27. It would be like that. It's the number that you get in the sequence. And n is the position in the sequence. So position, that would be like, is it the first number, the second number, the third number, etc. So here's my sequence. So if n is 1, we do 1 times 1, and we get k, which is 1. If n is 2, we do 2 times 2, and 4 would be the number in the sequence. 3, we get 9. 4, we get 16, and so on. So our sequence of perfect squares would be 1, 4, 9, 16, and so on. And that's the end of lesson